Hey y'all, today is March 15th and we are doing a lesson on simple probability. We are starting on page 5 in your packet. So turn to page 5 and let's get started. Okay, so probability. Probability is a measure of the likelihood that a specific event will occur. Probability is a measure of the likelihood that a specific event will occur. Probabilities have values between 0 and 1. Probabilities have values between 0 and 1. An event that is impossible has a probability of 0. An event that is certain to occur has a probability of 1. Okay? Now, finding probability. When all outcomes are equally likely, the probability of an event is the ratio of the number of favorable outcomes to the total number of outcomes. Now, key word right there. Probability is the ratio of the number of favorable outcomes to the total number of outcomes. Remember that word ratio is a fancy word for a fraction. So the way we're going to represent probability is right here. The probability of an event is the number of favorable outcomes over the number of total outcomes. So we're going to write it as a fraction. The number of favorable outcomes over the number of total outcomes. And then I want to point out this note right here. So probabilities can be written as fractions, decimals, or percents. They're all three correct ways to represent probability. However, on your BSA next Monday and on your test on April 5th, most of the time I'm going to ask you to represent probability as a fraction in simplest form. But I want you to know that probabilities can be written as fractions, decimals, or percents. Okay? So, our directions say to find each probability as a fraction in simplest form, a decimal, and a percent. So we're going to do all three right here. So for number 1, the spinner is spun once. Okay, well, there are 10 sections, so there are 10 total outcomes, right? So 10 sections, so 10 total outcomes. Okay, now the probability that it lands on odd, or the probability of an odd number. That's how I'm going to read that, the probability of an odd number. Well, for it to be an odd number, or for it to land on an odd number, it would have to land on 1, 3, 5, 7, or 9, right? Well, how many is that? That's 1, 2, 3, 4, 5. So 5 favorable outcomes out of 10 possible outcomes. Well, 5 over 10, I can reduce that. Well, I reduce that to 1/2. So, representing that probability as a fraction is 1/2. Now, what is 1 divided by 2? When I put that in my calculator to make it a decimal, I get 0.5. So 0.5 is my decimal representation. And then how do I make that a percentage? Well, in my calculator, I'd take that decimal and I'd multiply times 100, and I get 50. So 50% is how I represent this probability as a percentage. Okay, let's keep going. The probability of a multiple of 4. So, well, multiples of 4, in this case, we have 4, and then we have 8. And do I have any others? No, because it stops at 10. So just 4 and 8. So how many of them are there? Well, there's 2. 2 out of 10 possible outcomes. Can I reduce that fraction? Yep, 2 goes into both of those numbers. 2 goes into 2 1 time, and 2 goes into 10 5 times. So it reduces to 1/5. Well, to turn that into a decimal, 1 divided by 5 in my calculator is 0.2. And then to make that a percentage, I'm going to multiply that decimal times 100, and I get 20. So 20%. So the probability of a multiple of 4 is 1/5, 0.2, or 20%. Probability of the spinner landing on a prime number. We talked about prime numbers yesterday. So remember, it's a number that's bigger than 1, and I can only make it by multiplying 1 and that number. I can't multiply any other whole numbers to make it. So we're not even looking at 1. 2. 1 times 2. Can I multiply anything else to make 2? Nope, so I know that 2 is prime. 3. 1 times 3. Can I multiply any other whole numbers together to make 3? Nope, so I know that 3 is prime. 4. 1 times 4 and 2 times 2. Because I can multiply 2 times 2 together, I know that 4 is not prime. 5. 1 times 5. Can I multiply anything else to make 5? Any other whole numbers together? Nope. So 5 is prime. 6. 1 times 6. 2 times 3. Because I can multiply 2 and 3 together, I know that 6 is not prime. 7. 1 times 7. Can I multiply any other whole numbers together to make 7? Nope, so I know that 7 is prime. 8. 1 times 8. 2 times 4. Because I can multiply 2 and 4 together, I know that 8 is not prime. Okay, 9. So we've got 1 times 9 and 3 times 3. Because I can multiply 3 times 3 to make 9, I know that 9 is not prime. And 10. 1 times 10 and 2 times 5. Because I can multiply 2 times 5 to make 10, I know that 10 is not prime. So the only prime numbers that I have here are 2, 3, 5, and 7. So 2, 3, 5, and 7. Okay, so I'm just going to erase all this extra work right here. I hope you wrote it down if you wanted it. Okay, so how many prime numbers are there? Well, there are 4. So 4 favorable outcomes out of 10 total outcomes. Can I reduce that fraction? Yeah, 2 goes into both of those. So 2 goes into 4 2 times, and 2 goes into 10 5 times. So 2/5. Can I reduce that any further? Nope, I cannot. So 2/5 is my fraction. How do I make that a decimal? Well, 2 divided by 5 in my calculator is 0.4. Now, how do I turn that decimal to a percentage? I multiply that decimal times 100, and I get 40. So 40%. Okay, D, the probability of an even number or a number that's greater than 5. Okay, so an even number, well, we're looking at 2, 4, 6, 8, and 10, right? And then a number that is greater than 5. So greater than 5 would mean 6, 7, 8, 9, and 10. Okay, now let's actually, I started to write this down right here, but let me just do this on the spinner. So our even numbers first. We've got 2, 4, 6, 8, and 10. And then a number that is greater than 5. So it's bigger than 5, so 5 is not included. Well, 6 is already starred, so 7 needs to be starred. 8 is already starred, and now 9 needs to be starred. So all the numbers with a star fit that probability, that event, right? So they are my favorable outcomes. So how many stars do I have? Well, I've got 1, 2, 3, 4, 5, 6, 7 stars. So we have 7 favorable outcomes out of 10 total outcomes. Can I reduce that fraction? Nope, there's not a number that goes into both 7 and 10. So that is as simple as that fraction can be. Now, 7 divided by 10 gives us our decimal, which is 0.7. And then I multiply that times 100, and that gives me my percentage, which is 70%. Okay, let's move on to number 2. And I'm going to change my color here. Okay, and so we've already done an example where we convert from fraction in simplest form to decimal 2%. From here on out, I'm just going to do a fraction in simplest form, just because that is what you need to be most comfortable with. Okay, so a letter from the word acceleration is chosen at random. So I need to know how many total outcomes there are. That means I need to know how many letters there are. So when I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 letters, which means there are 12 total outcomes. Okay, that's important because that's going to be the denominator of my fraction every time, right? So now, what is the probability of choosing an R? Well, how many R's are in that word? Well, when I look very, very closely, I only see one R right here. So 1 out of 12. Can I reduce that fraction? Nope, I can't reduce that fraction, so that right there is my answer. That is my fraction in simplest form. If you want to, you can make that a decimal and a percent, but we're just going to work on the fractions in simplest form. Okay, letter B, probability of choosing a C. Well, how many C's are there? We see 2 right here, so that's 2. Any others? Nope, they're the only 2. So 2 out of 12. So 2 over 12. Can I reduce that fraction? Yeah, they're both even numbers. 2 goes into both of those. 2 goes into 2 1 time, and 2 goes into 12 6 times. So 1/6 is my probability of choosing a C. Probability of not a vowel. Well, that means any letter that's not A, E, I, O, or U. Okay, so any letter that's not A, E, I, O, or U. So it's not an A, it's not an E, it's not an E, it's not an A, it's not an I, it's not an N. So I'm looking at C, C, L, R, T, and N. So I'm just going to write that down because that's kind of a lot to remember. We have C, C, L, T, L, R, T, and N. Well, how many letters is that? That's 1, 2, 3, 4, 5, 6, right? So we have 6 out of our 12 that are not vowels. So that word just has lots of vowels in it. Okay, so 6 of our 12 are not vowels. Now, can I reduce that fraction? I know they're both even numbers, so 2 at least goes into both, but if I look very closely, 6 goes into both. 6 goes into 6 1 time, 6 goes into 12 2 times. So 6 over 12 is 1/2. Now the probability of L, R, or A. Well, how many L's do I have? 1. How many R's do I have? 1. How many A's do I have? 1, 2. So I'm looking at just those 4, right? So 4 out of 12. Does that reduce? I know 4 goes into both. 4 goes into 4 1 time, and 4 goes into 12 3 times. So the probability of L, R, or A is 1/3. Okay, let's move on to the next one. So Ryan randomly chooses a card from below. So how many cards are there? Well, 1, 2, 3, 4, 5, 6, 7, 8. there are 8 cards, so there are 8 total outcomes. And that's important for me to note because that number is always going to be my denominator, right? There are 8 total outcomes. So A, what is the probability of choosing a shaded card? Well, how many cards are shaded? I'm going to erase this here. The number of shaded cards that I have, we've got 1 here. So 1, 2, 3, 4, 5. There are 5 shaded cards. So 5 favorable outcomes out of 8 total outcomes. 5/8. Can I reduce that fraction? I can't. So, because I can't reduce it, that's my answer. That's my fraction in simplest form. Okay? Let's look at the probability of choosing a circle. So, probability of choosing a circle. Well, here's a circle here. 1, 2, 3. They're just 3. So, there are 3 favorable outcomes out of 8 total outcomes. So 3/8 is my probability. Can I reduce that fraction? Nope, I cannot. So that right there is my answer. Okay, let's look at C. Probability of not a triangle. Okay, so anything that's not a triangle. So there's 1 that's not a triangle, 2 that's not a triangle, 3, 4, 5, 6. So 6 of them are not triangles. So 6 out of 8 total cards, right? Does that fraction reduce? They're both even numbers. 2 goes into both. So how many times does 2 go into 6? It goes in 3 times. How many times does 2 go into 8? It goes in 4 times. So 3/4 is my fraction probability in simplest form. Okay, last one here, D. So the probability of an unshaded square. So an unshaded square. So I am not even going to look at the shaded cards. So I'm looking at the 3 that are not shaded. And I need one to be a square. That's the only one. So we've got 1. 1 favorable outcome out of 8 total outcomes. 1/8. Can I reduce that fraction? I cannot. So that is my probability as a fraction in simplest form, 1/8. Okay, let's move on to number 4. So number 4, a date in the month of September shown below is chosen at random. Okay, so we've got our calendar for September 2019, a couple of years ago. Okay, what is the probability of a multiple of 5? Okay, well, when I look at my calendar, the multiples of 5. So the multiples of 5 are 5, 10, 15, 20, 25, and 30. Well, how many days is that? That's 6. 6 days. That's the number of favorable outcomes. Now, how many total outcomes are there? Well, there are 30 days in September, so there are 30 total outcomes. I should have pointed that out earlier. So 30 is always my denominator. So 6 over 30. Can I reduce that fraction? Yeah, 6 goes into both of those. 6 goes into 6 1 time, and 6 goes into 30 5 times. So 1/5 is my probability. Okay, let's look at B. The probability of the third. Well, how many times does the third show up? Just 1 time, right? So there's 1 favorable outcome out of 30 total outcomes. 1 over 30. Can I reduce that fraction? Nope, I cannot. So that is my answer. That's my fraction in simplest form. Okay, let's look at C. The probability after the 14th. So after the 14th means every number after that date. So I'm not even including the 14th. So we've got this whole week. That's how many days? Well, that should be 7 days. This whole week, It's another 7 days. And then I've got another 2 days. So 7 plus 7 plus 2. Well, 7 plus 7 is 14, plus 2 is 16. So that means there are 16 days after the 14th, and there are 30 total days, so 16 over 30. Now, can I reduce that fraction? They're both even numbers, so yeah, I can. So what is 16 divided by 2? 16 divided by 2 is 8, and then 30 divided by 2 is 15. Can I keep reducing that? 8 over 15? Nope, that is going to be my fraction in its simplest form. So that is my probability for after the 14th. 8 over 15, sorry. 8 over 15. And then D, the probability of a Friday. Well, how many Fridays are there in this month? There's 1, 2, 3, 4. So there are 4 favorable outcomes out of 30 total outcomes. Can I reduce that fraction? Yeah, they're both even numbers, so 2 goes into both. 2 goes into 4 2 times. 2 goes into 30 15 times. 2 15ths. Can I reduce that? Nope, that's as simple as that fraction gets. So 2 15ths is the possibility of, or the probability of a Friday. Okay, let's move on to number 5. So we've got a deck of cards. It's chosen at random from a standard, a card is chosen at random from a standard deck of cards. So first of all, we need to know a little bit about a standard deck of cards. So I've already included in my notes this image right here of the 4 suits. So I know that there's the same number of cards in each of the 4 suits. Now I also know that ace is the highest. Then we have king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, and 2. So how many cards is that per suit? Well, if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 13 in each suit. So there are 13 spades. Then there are 13 diamonds. There are 13 clubs, and there are 13 hearts. So if I add 13 plus 13 plus 13 plus 13, how many total cards are there? There are 52 cards, which means there are 52 total outcomes. Okay, so that's a little bit about a deck of cards. Now, what is the probability of choosing a black card? Well, there are 13 spades and 13 clubs. 13 spades and 13 clubs. So what is 13 plus 13? It's 26. So we have 26 favorable outcomes out of 52 total outcomes. Can I reduce that fraction? Well, I know that 2 goes into both of those. So 2 goes into 26 13 times, and 2 goes into 52 26 times. Okay? Well, now when I see this, I can see very clearly that 13 times 2 is 26. So I know that this reduces to 1/2. So the probability of choosing a black card is 1/2. Okay? And there are other ways that you could have come up with that. You could have said, okay, well, if there are 4 suits and 2 of them are black, I know that 2 of the 4 are black, so that would be 1/2. Half of the deck should be black cards. Okay? Now the probability of choosing a 4. Well, how many 4s will there be? Well, we have this whole lineup 4 times, right? So 4 is going to show up once per suit, so 4 times in the whole deck. So there are 4 favorable outcomes out of 52 total cards. Well, I know I can reduce both of these by 2 because they're even numbers. So 4 divided by 2 is 2, and 52 divided by 2 is 26. And again, I've got 2 even numbers, so I can reduce by 2 again. 2 divided by 2 is 1, and 26 divided by 2 is 13. Okay, so 1/13 is the probability of a 4. Again, I could have come up with that a different way, because I could have said, okay, in the spade suit, I know that I'm going to have 1 4, so 1 out of 13 is the 4 that I'm going to have. So then it has to be the same for all the others, so 1/13 should be what the fraction reduces to. Okay, probability of a diamond. Well, there are 13 diamonds out of 52 total cards. Well, 13 out of 52. I want to know, does 13 go into 52? So 52 divided by 13, I do get 4. So I can divide both of these by 13 to reduce, and I would get 1/4. Another way I thought that that would reduce is because diamonds, right here, are just 1 out of the 4 suits. So I figured it would have to reduce to 1/4. Okay? And then the probability of a queen or a 2. Well, in each suit, a queen shows up 1 time and a 2 shows up 1 time. So I'm going to have 2 here, 2 here, 2 here, and 2 here. So 2 times 4 is 8. So that's 8 favorable outcomes out of 52 total outcomes. So I want to know, does 8 go into 52? So 52 divided by 8 does not work. So I know that these are both even numbers, so I can divide by 2. So 2 goes into 8 4 times, and 2 goes into 52 26 times. Again, I've got 2 even numbers, so I can keep reducing. 2 goes into 4 2 times, and 2 goes into 26 13 times. So 2/13 is my probability of choosing a queen or a 2. Okay, last one. So Christina is making a necklace using beads. She has 20 red, 14 blue, 10 purple, 28 green, and 8 yellow beads. She randomly chooses a bead to start the necklace. Okay, so how many total beads does she have? Because that's going to tell us our total outcomes. So I need to add all these together. So I'm adding together 20 plus 14 plus 10 plus 28 plus 8. So we have 20 plus 14 plus 10 plus 28 plus 8. And when I add all of that together, I end up with 80. So 80 is my total number of beads, which means it's the total number of outcomes. Okay? So now that we've established that, I know 80 will be my denominator. So what's the probability of choosing a blue? Well, it says 14 blue. So 14 favorable outcomes out of 80 total outcomes. Well, can I reduce that? Yeah, they're both even numbers, so I can. I know that 2 goes into 14 7 times, and 2 goes into 80 40 times. So 7/40. I can't reduce that any further, so that is my fraction in simplest form. Now the probability of not choosing green. Well, I know that there are 28 green. So I'm going to take 80 and subtract 28. So 80 minus 28. That's going to give me my number of favorable outcomes. So 80 minus 28 is 52. So I end up with 52 favorable outcomes over 80 total outcomes. Can I reduce that? Yeah, I sure can. So I know that 2 goes into both of those. So 2 goes into 52 26 times, and 2 goes into 80 40 times. I can keep reducing that because they're both even numbers. 2 goes into 26 13 times, and 2 goes into 40 20 times. I can't keep reducing that, so 13 over 20 is my probability of not green. Okay, let's keep going. See the probability of yellow or red. Well, how many yellows do I have? I've got 8 yellows and 20 reds. So when I add those together, 20 plus 8 is 28. So we have 28 favorable outcomes out of 80 total outcomes. Can I reduce that? Yeah, I know 4 goes into both of those. So 4 goes into 28 7 times, and 4 goes into 80 20 times. So I get 7 over 20. And finally, the probability of pink. Were there even any pink beads? There's red, blue, purple, green, and yellow. There's no pink. So there are 0 favorable outcomes for choosing pink out of 80 total possibilities. So that's 0. That is our probability of choosing pink. You cannot do it. So that is the end of our notes. We ended on page 6. Your homework is on pages 7 through 8. Y'all have a great day.